Well, again, I've got a bunch of printers behind me making a bunch of noise, but I guess we'll have to deal with it. We'll probably redo these videos again at some point in time, either with this model or maybe it'll be a new model. So I don't know, maybe it'll be quieter. There'll be printers running again. Who knows? But today what we're doing is, well, we've got to make a part. And I want to talk about first which part I'm deciding to make next. But before I talk about that, I've got some bullet points that I want to hit, hopefully in this video. But how do I go about deciding which part to do next? But even before that, there's a deeper conversation of what makes this be a part. And I can better explain it if I get this out of the way so we can see back here. When we start making a product, there are often, as far as design rules go, theory and such, there's going to be a lot of rules you break to get the model designed in. We talk about this thing called design in context, and that is a thing we'll mention kind of later in as we start to assemble more. But there's even, I think of it as a more barbaric design in context, where we're making this thing here be all one part to some degree. And we do this as a scratch pad. So that's one of the first things I want to talk about is designing, using Fusion, using your CAD software as a scratch pad to get the thing kind of mocked up the way you want it. And then what we're going to do is chop it up into pieces, or at least I'll show you how I did this. I chop it up into a bunch of pieces that I will call separate parts later, even though in the beginning, this green thing, the yellow thing, the blue thing, they were all one part, one giant solid. You didn't have this separation here. So that's very important. It's very helpful, I think, when you don't know what it is you're making. And this, by the way, comes from, you're inventing something. You have to either invent something as simple as a bracket that goes between this place to this place, like a known place and another place, or you have something like this, a product that you're making up entirely from scratch, and you don't have a drawing. You're not copying something that somebody else did so you can make measurements from it. You're not going off of a drawing somewhere that you can copy. So that's the context here, okay? So I'll talk about that, and then after you get everything all divided up into these separate lumps, you have to assemble them at some point in time. And if we say things like glue is not allowed, because if this was metal, if it was something that we did on a CNC, you're not going to glue those necessarily together. We have to have fastener holes. And so, for example, again on the side here, we've got holes that go through into this green shell of the inner sleeve area there. So that makes entirely, good sense there. We have to have that. But what hole are you using? So what type of fastener are you using? And are you counterboring it, countersinking it? And the fastener length, how far does it need to go? Well, not how far does it need to go, as in we can just arbitrarily go, I guess it goes about that far. We have to know what type of fasteners are available to us. So if I were to look at a cross-section, say right here, in this particular case, I have it counterbored maybe more than I need it to be, so that the fastener will stick through and a good portion of it will go into here. And that is also based upon the actual fasteners that you have or that you can get a hold of, you see? So that has to work. And then when you go to put this all together, let me back up. When you go to want to put it all together and you want this hole to align with this hole that's on this piece, these are two different parts at that point in time. So you need to come up with a scheme on how to lay out the hole pattern, say on this blue side right here. Come up with a standard, I guess. I mean, you could make it 52.315, but that's sort of an odd number. So maybe you do it like here, maybe to some degree in the center, or some known value from the front or the back or middle or wherever, so that when you get around to making this inner green portion right here, if I isolate this is down here, I can isolate it. These holes here have to match up, obviously, with those other holes. So how do I make these here? How do I place them? And if this part here slides up all the way against the front face, up to here, I better do this really well come up with some good scheme here so that when I go peeking through there, they line up. You see? Like that. So that's tough. That's some tough work. So considering all of that, what I think is maybe the best thing to go after next, I really was kind of flipping back and forth between the sides here and this inner portion. The sides have a lot, a bit more going on with them. And this has some really interesting features to it, this inner slide right here. But I think it's marginally lighter work than these sides right here. We'll do these next. Now, before I get started making that actual part, I want you to hold some stuff in your mind here as we move forward. This right here, this block, there's an interrelationship between, of course, all the parts here. So if you look at this portion of this rear block right here, it has some holes on the top that need to go right through to these holes right here. Now, if there is any great discrepancy in our print, these will not line up. We have a handful of things. We've got, this is one side right here. This is another side right here. These two sides are screwed into the front, and then they screw into the sides over here, which should not be an issue. It should be okay. But because of, due to, you know, the way that you print it, upside down, sideways, whatever, your printer may be, if you have any warpage on there, these holes might not quite line up. Now, it has not been my experience that that's happening too bad, so maybe that's a smaller issue. But the larger issue is one of tolerance. So when we go to slice this part all up, the big part I was talking about, when this is just one big solid block, and I want to start taking pieces out of here, like this inner slide area, the distance from here to here, from the side wall of this to the side wall of this, is 0, because it comes right out of this. Again, the blue and the green were one block, and I just sliced the green section out of it. Now, if we want this to fit, you'll put this in here and it will seem like it fits, but right up here it's very tight, and it will cause these back ends here to want to splay outwards. So it doesn't fit. What we need to do is accommodate a little bit, whatever it is, wrinkle discrepancies, air gap, if you want to think of it that way. Even, I mean, every part that goes into something, we add on or subtract a little bit of some material so that the fastener goes in the hole, so to speak. So we need to be able to shrink this green thing down from here to here, and this placement right here, the green up to this other green face right here, that's going to be pretty much spot on, barring any kind of lumps or bumps on the front surface of this green block. By the way, that might mean that you have to sand it down. So hopefully you have some sandpaper, like a 120 grit or something, that you could put on the table and run it on it and try to make this surface nice and flat. If there are any extra extrusion bumps, because depending upon, again, the way you printed it, that bump, if it's, half a millimeter, it's going to be a problem. Now over here, you can probably already see that there is a fairly seemingly substantial air gap. I can tell you that that is only 1 millimeter. That's 1 millimeter gap. And this is because if for some reason there is an issue with this, that this is hitting this, and because of maybe a bump or something like that, it might not, probably won't fit these holes correctly. And you could maybe get it to work, as in you could shove it in there, but problems all around. We want these fasteners to go through these holes pretty nicely, and as you see, we've got these recessed nuts right in here. So if the fastener has a lot of side load on it, it's going to be sticking out here kind of at an angle, and you're not going to get this fastener in here very good, the nut. Okay, so extra problems. So that's why we're leaving this bit of a gap. And I also, I guess you could say, which side did I want to put the gap on? And I guess that this seems probably the obvious side, but I did think about it, because I could have put the gap over here, but I think that felt a little bit better, to be sucked up over that side. So I put it on this side. That portion, all of those things are going to become kind of important. You'll want to know that. So when we get to this later, you can reflect back on this conversation, and hopefully that'll make some sense. Now again, realize that when you're trying to figure out how you're going to make something, you probably could think about it for a very long time and then make the part and still find out that that wasn't the best way to make it. So maybe if you just get to failing fast, as they say, figure it out along the way and then maybe rebuild it, okay? So here's how I am going to have us start this out. So we look at this piece here. First off, let me say that again, the yellow and the green, we're going to separate this later. So initially, this is going to be all one part, which is going to make things a bit easier. Now, also, as with the calibration square that we started with, this specifically what I'm talking about is how at the last portion of that exercise, I made the square entirely solid first, and then I cut the inner portion out. That's what we're going to do here. So instead of trying to figure out how you're going to draw all this in one sketch, that is almost always the wrong way to do it. What we're going to do is we're going to make a square. We're just going to make a centered rectangle that is the entirety of this whole thing, and we'll extrude that out. That'll be part one. And then after that, we'll cut out this inner feature. These little sections over here, we're going to worry about them later. We got a different little trick to do with those, okay? So I'll open up a new one. We'll get started with this. So what I'm saying is we'll pick this. Now, be mindful somewhat of your axes if you care. It doesn't really matter. So I'll pick this, and I'll go to a centered rectangle, and I'll bring this out. So that's what I'm talking about. We're going to have it just like that. Now, I want to go see how big I should make this. And remember, as we're going through here, I could put up here the dimensions. I could put up, let me show you here, the... something like this. I could put up a drawing and say, there they are. So here's the dimensions. This of course is the rear block. And that's fine. That's fine for real life. But the problem here with, in a training environment is, yeah, I do need it this shape, but I want it made a certain way. And these types of drawings, they don't get this across. So then similarly, I want to keep coming from the point of view where we have just made our model from scratch, the big monolithic solid that I was talking about, and we sliced it up into pieces. And we're going to use that to get our dimensions from. And the reason that is maybe different than what you're expecting, if I were to come over here and just measure this part from, say, this side to this side, we'll get 74.5, and that could be fine. You could come back there and you could put that on it, and that would be correct. But what I'd like to show you here is, let's see, let's unisolate this. And again, I gotta hide that. That has the tolerance on it. There's a little tiny gap right there. So that didn't exist in the beginning. In the beginning, I had just the big solid, and so what you want to do after you sliced it all up into its chunks, you would be measuring, well, the green block would actually be right up against this blue. It wouldn't have that gap in it. Or the other way we could do it right now is I could measure from this face to this face right here like so, and we see that it's 75. Okay, so that's 75 millimeters. That's what we want to go with, which seems really contrary right now at this point, because you'd say, well, that inner block right there, I already know it's 74.5. Why are we doing this? Well, let's dimension it, and then I'll explain. So we go here, and we'll say that this is 75, and then we need to know what the height is here. And this back and forth, I'm going to continue to do this because this is how you do it. This is how you do it when you have this big solid part. By the way, in a video after this, or maybe somewhere along the way, I'll show you this slicing bit so you can tell what I'm talking about. So then the next part here is going to be from right there, this flat face. Make sure you pick carefully to this flat face so they're planar to each other, two flat planes parallel to each other. And if you can peek in there, or you can look over here, we can see that that's 35. So that's the value that we want. There is that should maybe have a little tolerance, but this is going to be up to you. We'll talk about that later. If there was any kind of discrepancies up here at the top of the print or the bottom of this blueprint, haha, it would cause this green to not be flush with the bottom here. And does that bother you? If that bothers you, then maybe you'll add, you know, like 0.2 millimeters of some gap tolerance there. So this thing, you could think of it this way. Would you rather have the blue being down a little bit further or the green being down a little bit further? And if I had to make a choice, you know, again, this is going to be like a fraction of a millimeter off, but if I were to have a choice, I would like to have the blue touching the table, not kind of teeter-tottering on the green section. So maybe you could add some there, but we'll do that later. So 35 right there. D for dimension, bring this one out, make that 35. And now we're going to extrude it. Before we do that, we got to measure it. And so now the measurement of the green one here is a bit tricky because we, again, want to measure this, but we can't. So as you made this part, as you diced everything up into pieces, how did I come up with the determination that this piece right here was going to be how long? Well, I did it one way, and then I did it again, and then I did it again. And that was based upon things like, for example, this block right here, this green block, has a portion sticking out of it that kind of hits the back end. So that's going to be a problem later. It can go forward and it can hit the back end, but also I want to make sure that it had slide. I wanted to make sure that this didn't actually end up sticking out of the slide. So you kind of look at it and go, well, how far forward is going to be? This is just one piece of it, right? So how far forward is it going to go? And incidentally, that block sticking out, that might change in the future. There's conversation about the stability of this thing by making it longer like that. A good mill vise has a longer base on there so that this thing doesn't bend back and forth when you clamp something down. So that's a huge functional portion of a vise. But if it gets in the way, we might reduce it. Either way, though, when you look at this and you look at the back block that would be sitting here that I've got hidden right now, how far forward is this slide going to get to that and before it runs out of, you know, track to run on? So it's not perfect, but that's kind of the thoughts I was thinking. Now, I also knew that this back portion here is going to have something for this lead screw and thrust bearing to anchor onto and push against. Now, talking about the forces that are on this mill vise going back and forth, we are going to have forces along this lead screw on both directions. So if we're opening it up, it's going to be pushing against one side. If we're clamping it down, it's going to be pushing against the other side. There is a little bit of an idea that I might turn this in. That's what these soft jaws are for right here. I might turn it into something that maybe we could try to pull apart, but I can tell you that this thing is probably going to be entirely too weak to actually do that. When I was thinking this thought, the idea that you might do something like this tells you that you could also have, you know, if you're thinking the force is predominantly, you know, this thing is pushing forward, and so as you try to clamp it down, then the force goes on one side of the vise or another. If you try to pull something apart, then you're going to have a pretty strong force the opposite direction. So at any rate, that had to be sitting solid up against something. So now that's where this part comes back in. So this piece here has that hole inside of it that this thing is fitting inside of right there, and that has to be pretty tight in this particular case. And then to follow forward with this a little bit more, if there is a strong force on this, how much force is it going to take before it snaps this block off from this part right here? A little bit of a fillet right there, because I could to maybe help with that. You have to determine this, you know, what's going to be the force on this. Also, is it possible if you made this section right there such a thin wall, could you press through it? And that's not going to happen in this case, but if you only made it 0.5 millimeter thick just because you wanted to cover it, yeah, maybe it could be possible. So at one point in time, I finally ended up getting this built with the lead screw running through it, and I figured out what my open space was going to be, and then that's what I based the length of this off of. For right now, I'm going to tell you that our distance is going to be this edge right here, you know. Now, if you're not certain, if you zoom in really close, I can get that right there. And of course, you don't have anything to click on right now because you haven't made it. But if you're in this situation, you can either zoom in a lot or hide this part or whatever you need to do to actually get a measurement, because You might get this edge of this piece instead of the edge of this piece, and if they're not exactly the same, could be a difference. So I'm going to pick that face right there. You see I got it. And I'm going to go over here to the face of this yellow right there. So what's that distance? That distance is 170. Now I can tell you that when I go to make these things, it's not like as we put all this stuff together, it just happens to end up being wonderfully 170. I always round up or down my numbers to something reasonable if I can. If it has to be, some, decimal point value, then so be it. But if I can thin this piece down a little bit to make this a little bit longer or whatever, and the function still holds, so I can write something nice and clean like 170, I'll do that. So take that for what it's worth. So 170 right there. Now I can get back to this and I can extrude this 170. There's our block. I've went ahead and opened up the actual part. So this is, they're the same part, but this one is in the assembly, and this one over here is it individually. And the difference here is that down here you can see the timeline. So if I go back here, this is the timeline of the assembly as you brought the parts in and you joined them together. So you're not seeing any extrusions down here or sketches, anything like that. Over here, you do. So the reason I opened this up is, well, first off, I wanted to I wanted to look back on the ways that I did it, right? Because I didn't memorize the way that I make this, because every part is kind of different. And before I start doing a video and rambling about a good way to go about doing this, I thought about this when I built this part, which would be the best way to teach it. So I planned it out in that order, and I want to make sure I map to that. Now, the reason I'm showing you this right now is because I felt that this is a good opportunity to show you how to use the timeline. So this part here, you can see it's finished. But if I take this marker, a thing I can do is I can roll it back to the beginning, and there is my sketch, but it's hidden, so you can't see it. See, there's the sketch we just made. And then if I bring it forward just a notch, that's the sketch, that's the extrude, and that's the same thing we have over here, you see? Now, appearance, that's A for appearance, and that's how I made the thing a different color. It's not a huge deal right now, but I do like to make all my different part bodies different colors if they're going to be, well, pretty much all the time. But I was going to say, if they're in close proximity to each other and it's going to be hard to differentiate which ones are which, give them a whole pile of different colors, make them kind of a little bit on the lighter side, easier to see. So then the next thing I can do is I can go, okay, well, how was this done? So I scoot forward, and there's my sketch, but I can't see it because it's hidden. So you have to open up sketches, and then you hit the sketch, and you're like, oh, there it is. So this is what we're going to do on the other one. So you can see that I modeled a sketch a certain way, okay, and it's not quite arbitrary, maybe as you could imagine, and then I moved it forward a notch, and then I cut it through. Then the next thing that I did, and I'm not going to go through all of this right now, I'm just showing you how you can scooch the timeline forward. You could also come over here and you could use these buttons. So there's a new sketch here. I'm going to hide that sketch and show this one. So what's this sketch? Well, it looks like it's a square, but if you look closer, you can see that this is holes. So I do this all the time when I'm making these kind of, 4 holes for a bracket, a plate, a cover, whatever the deal might be. So you'd make a construction square first, that's the dashed lines, and then you make a solid circle. The solid circles can be extruded, the dashed lines cannot, so that's why the dash is considered construction. It helps us build the thing. And so if I scooch this one notch forward down here, and you take a peek through here, now if you look, it's going to be kind of hard to see because they don't go all the way through, but what I can do is I can highlight that right there. Sorry, I got to get rid of the sketch. I can hide the inside there, and then you can turn it a little bit. There's also a way to do section views, which I'll show you later, but I can see how deep that goes. So this is the hole that is going to go through it. This is something that I have to think pretty strongly about, how this is going to tie in with the other outside body. Now if you look over here, you see that it is not done on the other side, and this is a case where I like to use the mirror function here, this little triangle, and I've mirrored the holes from one side to the other, and I do that because, well, it's going to sound like it's out of laziness, but because maybe it's kind of work to make that square and put a bunch of circles there and constrain them all. And so I want to express that if you feel that you're using patterns, or, well, maybe not patterns so much, but mirrors or any kind of a feature because out of laziness, because you just don't want to, ask yourself if the way you don't want to is actually a better way to do it, and are you just being lazy? Now, the mirror function here, I liked this right now because remaking the square over on the other side creates a situation where you might make a mistake. There's other things you can do. You can tie them to parameters so you don't make mistakes. But in this case, I thought it was easier also for the group, and I thought it would be a good situation for this one to avoid any kind of mistake. So if I make some change over here, the change will happen over there as well. And for the history of that part, that will always be the case. Okay, so that's another thing that I check. Okay. I just wanted to show you that. So let's go ahead and get back here to making this. So I can pick a lot of different sides here. I could pick the back or the front, and that's all going to be fine. If I had a plane through the center or wherever, I could pick that. But in this case, I think it's going to be just fine if I hit that face right there and I go into sketch. Notice that I pick sketch first and then the face. You can do it either way you want. You can pick the face first and then sketch, or vice versa. Now, if I'm going to draw that shape out, I need it to be anchored to stuff, and this is where projections are going to come into play. So projections, if I turn this off to the side, the projections again are me picking edges that are somewhere else and projecting them onto my plane. Now, it's a little bit hard to maybe understand at this point because it looks like that face is on my plane, but let's just say for the most part those edges are not allowed. They're not selectable, let's say, on this plane. By the way, sometimes they are, but for the sake of right now, I'm going to project these edges. So I'm going to hit P to project, and I get this window right here. I pre-selected them. I held down Control and I selected all the edges. You'll see me do stuff like this frequently, one way or the other way. That's just sort of a random habit. Sometimes I select them first, but you can open up the project window and then pick them separately afterwards. Now, if I hit OK, it's going to be really kind of hard to see here, but they're going to be solid elements. So let me show you this. You can see points. Maybe you could see there's a faint kind of purple lavender color there. If I hide the body, now you can see that they're there. Now, they are solid, so if I wanted to extrude this, I could take this and I could extrude it out. And I don't want to be able to do that. I just want this as a guideline. So a good habit, let's flatten this back out. Okay, I could select all of this stuff here, and over here the line type I could change it to construction, and now they're all dashed. They're kind of hard to see, but they're there. To do that beforehand, I could go like this. I just deleted everything, and now here I'll hit P to project, and I'll select all my edges individually there. But make sure, you see how I'm getting the face, or I'm getting this face up here? Make sure you get just that edge. Okay, like that, and like that. Okay, so I've got all those edges. Before I hit OK, check the box. Check the line type here for construction. And then when I hit OK, you can see they're dashed lines now, right? So learn how to use that. That's hugely important. That's a very used, this concept right here is used quite frequently. Great. So now I'm here. Now I need to draw my shape out, and let's just get the basics done. We know that it looks like this. It's a straight down and kind of these triangles and flat. Okay, so if you can memorize that, I'm going to go here and I'm going to pick a line, but before I get started, I'm going to click on the background and I'm going to turn off line type so that this is actually a solid line. You see? So I pick this, and I'll just go straight across the top first. I'll go from here to there. You'll notice this, that with Fusion, this line continues on, but if you pick some kind of a point or a line, it feels like you're done. So it just has kind of like an auto finish, which is, I don't know, sometimes it's kind of irritating. But you'll know that it stops, so watch out for that. So I come down here and I go straight down. Now here's the thing, I showed in a previous exercise, I believe, don't worry terribly too much about where you're going. And in the beginning, sometimes as an exercise, it's even, I'll purposely make it kind of crazy. So for example, right there, it's 90 degrees. You can see the blue square in the corner. Is this supposed to be 90 degrees? It is, but let's say that I didn't want it that way. So I'm going to hold down Control so it's not snapping to anything. Then it's going to come out and make a triangle. What angle? Who cares? Just go like this. I'm still holding down Control. Everything is going to be crooked on purpose. Now I let go of Control because I can't snap to the endpoint. So I let go of Control and now I can snap to my endpoint. I think there's good value in understanding this and doing it this way first, because I think that people spend a lot of time trying to draw the shape perfectly and maybe not understanding or feeling well, you know, that your dimensioning is going to handle this. I mean, make it at least in the ballpark, you know, but don't worry about it too much. For the sake of speed, go click, 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 get it done, constrain it as it's supposed to be. So things I know I can do, I can come over here to horizontal, vertical. I can pick this one, I can pick that one, so that's straight up, and this one should be flat. These ones I don't know, let's say, quite yet. So I'm gonna hit escape. What I do know, though, is that this point here and this point, or the length of these two lines, is going to be the same. So here's a trick that I do fairly frequently. You don't have to. There's other ways to do this. There's a million ways to do everything we're going to talk about. So I go over here and I change the line type to construction, and I pick this point here to that point there. What's the benefit of that? Well, now I can come over here and I can say that that is vertical, and it's going to straighten, or horizontal, and that's going to straighten these things out. I can do the same thing with this corner to this corner, if I believe that now and forever that those things are going to be even with each other. I could have also done a line up the middle and made them symmetrical, which is going to be something we're kind of going to do anyways. So I'll flatten this out. See? So that's all nice and even. I do like construction lines like this, though, because if I ever needed to dimension, say, from here to here, oops, I can pick this one to this one right here, if I could actually learn how to select and distance them that way. You can also pick the points, but I like that better. So kind of a preference. So then, like I said, we know that these ones here, they're going to be symmetrical across the center line here. So I can pick a line tool again, and sometimes I make the line go through the whole part because it's easy to see. But if I know I just need a mirroring element, it doesn't have to be any length. It just needs to be there. So I pick it from here, and then I guess I'll just snap it right to the midpoint right up there. And now, even though these ones are down here, it's okay. I can still make them symmetrical across that line. So I can pick this one here, that point, and that point, this point, that point, and this one, and this one. Okay. And if you were to go too far because you're like, oh, I need to do these, which you don't have to because they're perpendicular to this line is already done, you pick it, and then you get a little red dot down here, and then there, a little arrow pops up, okay? Because it's already there. It's already constrained. Now, there is a bit of an aesthetic, I don't know if it's OCD or what it is, you know, we have our certain ways we want things to look. And what I want to show you here is I could do this as well. Similar to these lines here, I could say, well, this line from here to here, this is also going to be, they're going to be tied together. They could be symmetrical. I could do it the same way. I could do it this way. So I go here and I could straighten those out, and that one will comply because it's a mirror. Now, that makes this point, you know, symmetrical, and everything's looking pretty good. Right now, if I were to grab this line right there and move around, you can see, you know, it goes up and down. So I do have this midpoint thing that we used before, but it's not going to work in this case. I can't make this line and that line be midpoint. It's not going to work. I could make a little short line on top of this line that goes from right here to that midpoint. I could do that, or I could just make it symmetrical. This is hardly barely the main point I want to make. So let's get this done in one form or another. The quickest way right now is I could make a line. Later I would do this with dimensions, but I could take this and I could look for, there's the triangle. You see that? Okay, now I could make that line horizontal. This is a crazy way to do this, by the way. It's, you know, but it's there now. I just want to get to this next part of the point. Usually I would make this thing be a dimension right here from this line to the bottom line, and that midpoint right there would be half of that. I could do that, but we're there now. So let me keep going here with some dimensions, and we'll see what problems we run into. So I'd like to do this one next, this piece right here. So if I go back to the main model, it's a bit maybe deceiving. So it would look like it's this, but remember the block is this inner piece. So it is this piece. Let's go here, measure it. So we go from that piece down to here, this point. Be careful picking a point to a point because it'll give you the straight line. This is why I'm picking a plane right here, maybe not something like that. But if you got a flat plane, then I can pick a point like that right there, and that is 5 millimeters. That gives us the dimension we're after. So that's 5 millimeters long, that one piece there. So I can add that in. And so then what next? So I can go here and I can wiggle this up and down and around, right? So how about this gap distance there? Now again, we're going to have some tolerance on this, but what I want for right now is just from face to face right there. So that distance is 30. Okay. Then to finish this up, if I go over here, I can measure, this is kind of hard to see, but I'm going to measure from that point right there to this point over here. I know they're symmetrical across, so I know that that distance will be accurate. I can pick from here to here, and what you'll find is it's going to be 60, okay, 60 millimeters. Now, know that when I originally made this, this was all based upon the lead screw going straight down the middle of the main body. So the lead screw, the center point of the lead screw is 20 millimeters down. This is 40 millimeters tall, so it's 20 millimeters right smack through the middle. Then after that was there, then I put the thrust bearing on the handle and everything, and the front face has a hole in it. Everything matches up with that 20 millimeters down, or the center of the blue base of the body. When it came time to doing this part we're working on now and the slide that it runs on, this center section with the blue and the different colors here, we'll explain when we get to them. But I needed this to be right on the money where the lead screw was, but some symmetry is kind of out a little bit, and that's just an OCD thing, so I'll explain here in a minute. So that's 60 across. Let me just get the dimensions done, and while I'm here, I might as well measure the top to the bottom as well. So we got 60, and then from here to here, we've got 24, okay? So from here to here, or the length of that long line that we had in there, make that be 60. And then the length of this line here is 24. And now it's black, meaning it's all iso-constrained, and there it is. I'll turn the body back on here, and now we can cut this thing through. So now we can extrude that part right there all the way through all. Remember that? So through all, and there is our slide track. So now we've got to make some holes. That's at least our next step as far as the way that I designed it goes. So we're going to put them over here on this face. And now if I were to go here, let's just turn around and flatten out to it. If I were to make some holes in here, it would very much stand to reason that I would like them to be symmetrical and maybe, you know, an edge margin of 10 or something. So we got a hole here, one here, one here. It maybe makes less sense to have one hole here, and then another one here, and no holes over here. Right? You see my point? We want it to be not symmetrical just for OCD, but we want it to be, you know, an even edge margin so it holds this part correctly inside the frame of it, right? So again, if I just put a couple holes over here on the side, this side is going to be maybe inclined to want to fall out. So holding things even, pretty typical normal stuff, right? However, if we go over here and we look at this, again, you see that this piece here is not the same as this. So think about it and go, is this going to be okay? Well, yes, this is being held inside here. So I'm okay having the holes on the green block here being symmetrical, you know, even from the edge, but they will not be on the blue part, right? which means that when we get to this blue part, what we're going to have to do, now that you understand projections, or at least, you know, construction lines and that sort of thing, we're going to map out this green block on the side of this face here, so I can make these holes here still with maybe something like a centered rectangle, so it's even, but inside of this section that we quarantine off that's the same length as this. So for right now, pretty easy. We're going to pick the side of this face, go here, and make a centered rectangle. But as you notice, there's nothing really to snap to here. So what I find is easier if I know that I need to do top, bottom, left, and right. Often I don't really know which one I'm going to use, top or bottom, so I just project everything. So I'm picking them, I hit project, they're going to be a construction element, and I click. Okay, I'm going to start going a little bit quicker. Now, they are, if I hide bodies again, they are construction elements. You see, construction elements is still on. So now I'm going to grab a line, and I'm going to go from here over to here. And that's actually pretty much sufficient unless I need a symmetry line as well. And so I'll find the center line here, right there, like so, and I'll bring that up to there, possibly, just in case, right? It also gives me an actual point, even though I did have a midpoint. Now, centered rectangle, right smack there. Oops, gosh, twitched. Bring this out, and then we want to dimension it. Now I could do width and height, so I could just say that it's so wide, up and down, or I could make it an edge margin. So you kind of decide what you think is best. Now, to show you how I roundaboutly get to this dimension, I'm going to add my circles in. They're not going to be construction elements. I'm going to add a circle right there. And this is going to have, well, no counter bore on it. But if we go over here, this does. And you could say that that doesn't really matter because it's not the part. But if our hole is too low down here, because it seems like the edge margin is okay for just a 3mm hole, if we don't account for the counter bore in this part is going to be down coming out at the bottom of the part. So I'm going to come over here and I'm going to add another circle to this, like so. So I'll dimension the inside one here. This is going to be 3. So that's pretty tiny. And the outside one, I'm going to make it, well, it's 5.5. I could make it 6, but I'm going to go ahead and make it 7 just so I got extra clearance. So it becomes easier to see. Now, I'm not going to do any counter boring with this one, so I could turn it into a construction element if you can see it okay. Now, I'll go around and, well, this should be sufficient for this one, but I'll add all my other holes over here. So I'll do this, this, and this, and then I'll dimension them afterwards. And, of course, I will make them, oops, the same as that one right there. And I'll get this one out where I can reach it. So you can grab this and you can move it around and kind of see where you might want to place this. If you wanted it, you know, right up here in the corner or something like that, then yeah, you can get it right there. And then I'd say go ahead and measure it and make it a decent normal number. Again, not like a deep decimal. And in this case, I felt it was a bit better to kind of bring it back in a little bit. And so I ended up making it 130. Then the height over here, this is kind of interesting. The height is 23. So I can put in 23. That's what I'll do. But the way I originally designed it, the way it is designed, is to have a 6mm edge margin. Here's some, maybe not exactly a problem with this, but here I'll show you. If I were to inspect this, I go from this edge to right there. Not the face. If I go from this edge right here to that line right there, 6mm, it's a symmetrical rectangle based off the center, so this one here is 6mm also. Now when I go to do those holes in this side block, my edge margin is not going to be the same. I can get it to work, but when I went to do it, I said, you know what, let's find the edge margin first, and then measure what this is and make it this. So now I just remember 130 by 23. I could easily see going the other direction with this, okay? I did this way because I felt that later down the road it might be easier for me to remember 130 by 20 based upon the center of this thing. Oh, and actually, before I forget, this 3mm has to be 2mm because we're going to tap this. So you're going to see this in a second. So the hole in the outer frame that goes, the fastener will go through and then get to this, that's going to be, you know, just slide the 3mm through. But this one's going to need to be tapped. And that's a little bit of a problem because this is kind of a deep hole, and tapping the plastic is kind of messy. You're probably going to screw the threads up. You have to run it in, run it out many different times. It's deep enough that you'll have a buildup of plastic particles. So you got plastic particles getting all in it as you try to pull it out and remove it, which ruins your threads. But if you keep running it forward into it because it's a blind hole, the chips don't come out the other side or anything like that. I guess you could make it a through hole, and maybe that would help. I don't really exactly think so. It's just a pain. It's just a pain. Now, we could do a heat set insert on this, which might be the future of this. And then what we end up doing is we enlarge and embiggen. Yeah, we'll open this hole up to something like what is it, like 6mm, 5mm, whatever the width of the heat set insert is. You know, less a tiny little bit. Shove that in there. That would be great if you get it perfect. That's the problem with the heat set insert. So I'll go ahead and extrude this while I'm yammering. You go ahead and you put it in the hole, but if you do not get them axially perfectly straight, and you have all these holes that are dependent on it and parts that took a long time to print, you know, it could be a big pain. So if you want to give that a shot, you could. You know what? I'm going to call an audible as I'm doing this. I'm going to go ahead and make this, so you look in the side here. How far in do you want this hole to go? 10 seems sufficient, so I'll have to remember that we got 10 on this side, and then maybe 10 on the other side for a 20mm fastener. This is, by the way, hold on to that thought. I didn't mean to sound like it's an afterthought. It's a big deal. We have, you know, our 16mm fasteners, 20, we've got 25, we've got 30mm fasteners. So we have to be aware of that fact. So this hole right here, if it's 10, when I go to make the other side, where the counterbore ends, I need to bring the depth down enough to where on the outside frame part, I have an amount that doesn't make it too deep or too little to get into here. So I'm going to go with, like I said, maybe a 20. You could go with the 16, and it goes in there a little bit further. But we'll say, how about this? We'll say minus 12, because there's no harm in going a little bit more forward with this. There's our holes. So, like I said, what I'm going to do is, if we got 10mm in there, the heat set inserts are about 5 or 6mm deep. I don't have one near me to measure right now this instant. So what I'm going to do, though, is I'm going to go ahead and take this one right here. And actually, you know what? We can leave that one there because it's good for our purpose. But I'm going to add in another one. We'll make this 5. Hold on a second. I'm going to pause, and I'm going to go measure the inserts. Okay, so the inserts are 5.5 in diameter, so I'm going to make this 5 because it will give material, it'll allow for material to melt into the threads, if you want to call them that. Then we'll, when we get done, we'll add a chamfer to this. All right, I went ahead and finished the circles there, so I'll get back out of that. I'll extrude those inward. Now the depth of the insert is 4mm. They do change. There's different lengths of them. So what I'm going to do is I'm going to say -6. So that'll give us plenty of room. And now I can hide that sketch because it's in my way. And to make life a little bit easier, with the heat set inserts, it's kind of nice if you add a chamfer. So the first time looking at this, so our chamfer is fairly self-explanatory. I pick this edge and I bring it in, and it does that. I have a few different ways to go about doing it. Just leave it like this for right now. and I'll pick all the rest. If you pick one and you do what I just did, wiggle around, you'll find that you can't pick the others. Fillet might end up doing the same thing. Hold down Control, and now I can pick them. You see, if I let go, then it does it. So I hold down, pick, let go. There's my chamfer. So how much do you want to do? I just want to do like, what is that? I think that's probably about okay. See, this is kind of an oddball number. I don't really care horribly, terribly too much. I think maybe 1 millimeter might be a touch too much. Let's see, what does that? No, 1 millimeter is fine. So this is what I was talking about earlier. I'll clean it up with some nice normal number. Hit OK. And now I have a hole that should, this might be great for a couple different purposes. So that gives us still, 5 millimeters. How deep did I just make that thing? 6. So it'll give us enough to tap into if we want, if that works. But if that does not work, then we have a hole here for our heat set insert. We might even try the heat set insert first, and if that doesn't work, then we can fall back to the holes. So we've got either or. Now the chamfer is to help with the excess plastic that melts out to give it somewhere to go. So as you stuff the insert in here, the plastic around here is going to start to melt into the little grooves and such in the insert, but some of it invariably is going to come up and out, and that's what the chamfer is for. Okay. I feel it also helps us kind of align the thing a little bit better as well. Probably a little bit of imagination, maybe not, right? But we have it. So hopefully this works out okay, and I just didn't screw us up royally because we had a pattern and I just deviated from it, but we'll see how it goes. The thing that is an upside is a big deal with CAD design is going back and editing and fixing. So if anything down the road does end up horribly screwed up, it's okay. It's just another video. It's another, time to learn how to go back and edit things. So now we need to get these holes here over to this side. And like I showed you before, we're going to use the mirror function. So we go up here, go to mirror, and we have to pick our stuff. Now yours is going to default to probably faces, which could work, but what you'd have to do is get into here and pick every single face that you see here and everywhere else. And so that's not going to, it's not the best. What's probably the best, at least in this case, is if you go to features. So features are these things down here, all the stuff in the timeline. So we're going to pick all the stuff that made these holes, but not the sketches. So it's going to be this extrude, that extrude, and this chamfer. Now, yours is also going to be most likely defaulting to adjust. And if I hit this, so watch. So I've got my 3 things selected, and now I have to pick a mirror plane. So I pick this, and now my origin shows up, and I can pick this plane right here, which is, again, why we frequently try to stay symmetrical if at all possible. So I pick this plane, and then they'll go over to there. However, if I hit OK, I'm going to get an error. So there are different ways that you can mirror. There are also sometimes you could say there's features that it doesn't like. And what's the doesn't like? Well, let's go back here. And if I were to pick the extrude, this extrude, skip the chamfer or fillets, they tend to have a bit of a problem. And I'll say mirror across this over to there, and I hit, oops, let's change it back, is on adjust, and hit OK. It will work. But I don't have the chamfer, so then you can come back by and you could do the chamfer. Or you could do it before you did the chamfer and just do them all in one shot. Or you could play around with your different options with the mirror function feature. So features here, I could pick this, this, and that. And then my mirror plane is this. And then if you want, hover over these. It'll tell you optimize is the same as picking all the faces, but without having to pick all the faces. So whatever is there, it'll say just do it over here. Whereas these other ones kind of keep things in mind, like, for example, through all or up to that feature or over, to this thing or along this thing. And if that thing isn't over also on the other side, then sometimes it has an error. So if I hit this one with optimize, then it works. Okay? So however you want to do it, as long as we make sure that they're exactly the same on both sides. there are our holes done. Okay, so we're getting kind of to the home stretch. This next part is kind of strange. It's going to seem probably kind of strange. This is the point, we're at the point now where I want to divide this into two separate bodies. So let's take a moment to talk about bodies, and maybe we should talk about this also in contrast with an assembly component. So one part, one body, let's start with body first. A body is what you're looking at here, one homogeneous solid. If I were to make another thing here, let's do this here. I'll just make it on this plane right here, but I'll make it over off to the side, something like this. They're not touching, right? So as you see right in here, it says new body, as opposed to join or remove. So now I have this body and this body in the tree, and if I hide this one, it goes away, and so on, right? So two separate bodies. Does this mean that they're two different parts? Well, technically no. They're still part of the same model here, and so we'd say this is one part. It gets to be a little of a gray area, which if this was CATIA, I would say, if this was CATIA class, I'd say, hell no, there is no gray area. This is a part. I don't care what you say, this is a part. And if you wanted the two things separate, you made it incorrectly. So a component, a part, a component is like this. This is an assembly, and each one of these items here is their own part. So this piece right here, or the knob, for example, if I look over on the side here, there's the knob. It's all by itself, okay? It's not an element inside of one component. So what's its purpose? Well, the purpose of different bodies is, well, probably a little bit tough to get into right now at this moment until we start to do this, which we will be doing in this lab pretty soon. But roundaboutly, maybe I could say it like this. We use different bodies to achieve results on the part that I want to work with. So maybe, for example, it was easier for me to draw this block and I add some features onto it, whatever I want, and then maybe I take all of this stuff and I remove it from this block. So like if you're making a mold, I would make the thing that the mold makes, and then the mold would be a block like this, and I would stick said thing into the block and I would remove it from it. So now I'd have a cavity in the block. So that's just about the most simplest I can say right now at this moment, right? They're a little bit strange. So what I want to do is I want to split this. So there is a feature here called split body, and it takes a body and it cuts it up into pieces. So let me show you the quickest and the simplest way to achieve this. I could say, okay, split body. I need to have the body to split, and then the splitting tools. What could be the splitting tools? Well, notice this plane just lit up here, so maybe I could pick that. Well, I pick the plane and this circle comes out because it is a circle that envelops the entire thing. And if I hit OK, now it doesn't look much different, but I have a seam line down here, and I've just effectively divided this into two parts. You see? Now I've got two different bodies. Here is how this affects us with printing. I now can print this in two different pieces, and this could be very beneficial for time or size. If your print bed is only so large, maybe you can't fit the whole thing on here. So if you divide it into pieces, now I can go to make and make an STL or a 3MF file out of this, and I can get it to my slicer. Cool. This also will start to bring up things that I've been talking about a lot without, again, a whole heck of a lot of context. If I were to cut this in half and this is the only thing, there wasn't these holes holding it to another structure, I would need to come up with a way to fasten these things together. So before I actually send this to the printer, I'm gonna have to get in here and I'm probably gonna have to make some holes. I'd have to put some holes over here and maybe some flanges down here, some way to anchor these things together after I print them, okay? So at any rate, that's not what we're here for. That's not what we're going to do with this exactly. We need to get the inner slide track out of this, because the purpose, the idea behind this, whether or not we do it or not, or you do it or not, is to use dissimilar print materials with our IDEX printers, the independent dual extruder printers. The benefit here is that I can have this slide, this inner portion, that doesn't take as long to print as the entirety of the whole base, including all of this. So there's that. But I can have this with another element on the inside of an entirely different material that is maybe more resilient to abrasion, because we're going to have the inner part of the vise here sliding back and forth, than say the outer. You could print the whole thing in the less abrasive material. However, that might be more expensive, which is usually the case. So we're going to slice it out. And the way we're going to do this is we're going to, well, first make a sketch. Right, so I'm going to pick this face, get back over here to solid, and I need to create kind of an outline around here of what I want to slice out. This again is going to be a little bit strange. So I'm going to get me some projections here, and if I remember right, I'm probably believing I'm going to need to pick all of these edges here. Because what I want to do is I want to make a sketch that is my control key suddenly not working all the time? Okay, I need to project these because I'm going to make a line that goes right around here. So P to project. And this is going to be a construction element. And I'll hit OK. So then I'm going to hide the body so I can see this easier. And then what I want to do is I want to outline the thing. You could maybe do this differently, but here's the way that I want to do it. So I pick a line, and right now, don't snap it to that midpoint right there. It's going to seem very like it's a good thing to do, but don't. So purposely move it off of it. If I hold down Control, it won't snap, but it won't snap to the line either. So I'm just going to grab somewhere kind of small, low down here. Now I am going to hold down Control because I don't want any automatic constraint being made if I happen to line up with something. So I'm holding Control the whole time I do this, letting go middle mouse to move it across, holding Control down again, and then I'm going to bring it back and I want to snap to the line. I can't. Oh yeah, let go of Control, snap it, not in the center, down a little bit lower. Okay, so there's our shape. Now come up here to parallel. I hit this constraint and I can pick this and that. Now they're parallel. This and that, this and that. If I try to make a measurement out of these and they're crooked, I'm not going to get a distance, I'm going to get an angle, and that's not what we want. So we parallel them first, then I can go to dimension and I can say that from here to here is 2. We're going to make that 2 millimeters. Then go around the way here and make all these equal to that one. Okay, so now we're done, but it doesn't look like we're done. It doesn't seem like we're done compared to the way we've done things before, because we've learned that if you're making something to be extruded, seemingly, you would want to make it a closed entity, which, yeah, you would if that's what we wanted to do. I'm going to turn back on body, and I'm going to finish the sketch because we're not going to hit E to extrude this time, not exactly. We exit out, and then what we have to do is we have to make, we have to do a different type of extrusion, and this is part of surface design. So now we're leaving this area here with all the tools that we've been learning right up here. We go now to this tab that says surface, and it has a whole lot of other things. We're going to use it for basically one element, and that is the extrude, but it is the surface extrude. This extrudes single lines, whereas anything extrude in solid modeling would not do that. So this is very helpful to know this in many different cases. But in this case, we're going to use this as a way to separate this solid that we have here, our body. So you see what I'm doing is I'm pulling out that, and notice they give it a little bit different color to indicate that that is a surface. And I'm going to change it to 2 sides, and I'm going to grab this and I'm going to bring it through to the other side, stick it out here. Now, You didn't have to bring this out all the way. I'm doing this more for the sake of a visual rather than anything else. You could say that it's just going from this face that we made it on up to this object here. You totally could do that. But it'll also make it easier to select, by the way. So that's it. That's all there. So I hit OK. Now I've got this element running through my part. So I want to show you another feature of surface design that isn't necessarily needed right now, but just in case it ever was, it's kind of nice to know about this. Sometimes you go to divide things, and maybe this line right here isn't exactly perfect. In our case, it has to be. But what I could do is I could actually go here, and I could go to extend, and this will allow me to take an element like right there, like that line right there, and based upon tangent to the previous line right here, it will extend that out. And so I could do the same to this one over here at the same time. I could grab them both and I could extend them out a little bit. So this is a whole different course entirely in itself. Surface design is a big deal, and I would say spend a little time over here, because it's after you graduate from making lots of nice little square-ish shaped models, if you need to do anything with a curve, constant varying curvature, surface design is really where it's at. So after we have this, now we can go back to solid, and we can use this as our splitting tool, just like we did a moment ago with the plane to cut the thing in half. Then what you're going to do is you're going to come back here to split body, but well, let me do something kind of wrong here, just so you can kind of remember this. You go here, and then you have to make sure you pick splitting tools. Don't just keep clicking, because otherwise you'll be adding it to the first. You go to splitting tools, and you go, okay, I want this. But if I pick that, it's only going to use that face. And so then if I pick the next one, uh-oh, I got some kind of weird error. And so if you go through this and you pick it and you pick it and pick it in all these different ways, it still doesn't really work. Depending upon what you're doing, maybe it will, but it's not going to work here. What you want to remember is that you want to go pick this, and then the splitting tool is this entire body over here. Remember to use this side as tools from time to time as well. So you go over here and you pick body 4, and it says, oh, okay, I got you, the whole entire thing. And this is normally checked by default. It doesn't really matter, but it's going to extend it out until it goes through all of the body that you're cutting. You hit OK, and that's it. That kind of maybe doesn't look terribly too much different, but if you look in the tree, we have an extra body. This body here, our cutting surface, we can hide that, and now you can see that we've got a seam line right there, and they're two separate bodies. So then to make this a little bit more clear, this is where the appearance comes in. So I'm going to change this to some color, right? And so that's currently the whole thing. But I will go down here to, I seem to like the metal ones, and so I'll go here and I'll bring this blue onto that. Or you could drag it up here, but sometimes these get in kind of a wacko order. You can also name them, by the way, if that's helpful. I'm going to bring it onto that one right there, and now that's blue. Even though it's, glossy blue, you can name it, or you can change it to whatever color you like. Okay? So now we can clearly see that there's two elements inside of this. Now this one here, it's a different body. We could print them separately, but they do kind of go together. Later on down the road, if I was really following protocol, I would remeasure these things here like I just did from the beginning, and I'd make it as a separate part. But we're not going to do that. There's always seems to be kind of a line where you draw in the sand of, I know it's protocol to do it this way. This is fine. It makes better sense for a lot of different things, especially what you're going to see in a moment, what we're going to do. So the next thing we're going to do is to hollow this out a little bit. So we don't really have to. If this was aluminum, we wouldn't go through this effort, let alone the thought that you couldn't really even at least easily do this. But since we're printing all of this, why not lessen the amount of material but still retain structure, right? So we're going to hollow this yellow section out, and we're going to use a tool called the shell. And now the shell, I'm going to make something really quick over here just to demonstrate. It has a name, like all things do, but I'd like you to realize that just because a thing is named something that seemed like it was sensible to call it this, doesn't mean that that's exactly what it is. So a shell makes a thing like a seashell, like the shell of something. So if I were to hit this, I pick a face, and now I can grab this, and I can bring this in, and look at that. So now I have a box, right? A hollow box right here that has a uniform thickness on all sides of this mount, 2.642. But that's also inclusive on the bottom down here as well. The entire thing, all walls are that, right? So let me cancel that. What I'd like you to maybe think of it as is remove face and leave thickness. Because you can do this, for example. I can pick this face, and I could pick this face, and then I could hollow this out, you see? So it removed those faces and allows me to leave a thickness behind. That also gives me the ability to do stuff like this. So I can pick this face and this face, and now I have a tube. So that's maybe not something that at least maybe was intended with the shell tool when it was originally created. It could also be a really interesting way to just get a 90-degree angle bracket, you see? Cool. So to apply that to ours, what I'm going to do is I'm going to hit this face and the back face here, and we're going to hollow everything out. But we happen to have holes that are going through here. So what's that going to do? Well, if we come back over here and I pick this face and I put a circle on it just somewhere, how about right here, and maybe I'll add another one. How about that? And then I'll extrude them down through, all the way, through all, hit OK. And just because we have it there, why don't we add a chamfer as well? It's going to happen if we do that. There you go. Okay. Now, if I were to pick shell this face and this face, what do you believe is going to happen? Well, like I said, it's going to remove these two faces that I selected, but it's not going to remove any other faces. Any other faces, it's going to leave an offset thickness equal to the amount that I slide it. So these holes will become tubes on the inside, you see, with a wall thickness of 2.679 millimeters. Okay. So back over here, the holes that we have going through will remain holes all the way through and have structure where it's going to be hollow and maybe give us some appreciable amount of reinforcement for the body as well. So we'll go here and we hit this face there and this face over here, if I can actually pick it, and then we're going to open this up and a mount. So you see, look in there. So now we've got our counterboard, countersunk fastener holes here. You see how that works? So how thick do I want this to be? Well, you would be inclined to say, well, thick enough to be strong. Okay, that's totally reasonable. But I would add on to that, since this gap distance here is probably not much more than 1 millimeter, if I bring this up a little bit more until maybe they're touching a touch, then what I can do after the fact, now that they become one here, I've got an edge that I can add a fillet, and then I could definitely reinforce that a bit better, and I've got a better structure overall. If I leave it kind of thin like this, not touching, you can kind of see how this could wiggle around a little bit. We might have to actually add structure later to help reinforce it. So I'll thicken this up, and as you see, I mean, if I go with 2 millimeters, that'll be fine, just barely. Now, if you look inside here, though, it might not be a huge deal, but this continues on through into here, up to here, but it doesn't go all the rest of the way. Is that a big deal? Well, it will perform its function. It's still a hole. Like I said, there's no, it's not cutting through in any shape or form, but maybe I like this as a structural component in here, and if I extended it out, it would anchor a little bit better. And it's a tool I get to show you. So I'm going to make it 2 millimeters, hit OK, and there we have it. You see? So one tool got rid of a lot of material that hopefully would save a lot of time in printing. Now, to get this to work the way we want it, now what I want to do, as far as these things going up to this surface, I'm simply going to use the extrude again. So I can hit extrude, but I can pick just that face right there, and I can say extrude to object, and I can say up to this object. This is going to work just fine. However, I can't pick all of them at the same time. So I can pick these ones, but if I pick these ones right here, so you see here I've got two object and this one here, I can pick that one right there, that face. And then as far as going up to object, well, see, if I try to pick this one, it doesn't like that at all. So what I will have to do, if I want this to work, I'm going to have to pick this one. The one over on the other side shares this face, so that'll be okay. You see, I could do that, and then go around the way. Then the last thing we're going to do with this is, if you felt like it for aesthetics or structural, we're going to add some fillets. So the main thing is we're going to put some fillets in these corners down in here. You could even get in here and add a little fillet to each one of those if you wanted to. It wouldn't be very much, but if you felt that it needed it, you could do that. So I'm going to hit F for fillet, and then I'm going to pick that edge right there, and then that one, and so on and so forth. Now, because our counterbore got kind of chunky, we have to get the other edges here as well, and that's going to make things a little bit more complicated. But Fusion has this great thing where they allow you to pick things like an x-ray through. So I could come over here and I could get that edge right there, you see? Just make sure that you really did get everything. And then since we did, went astray a little bit from my plan, let's see how this is going to work. So what's going to happen is this is going to round this out, but right where this is, it's going to kind of smooth into there, and it could cause complications. Oh, wait, did we miss something? Nope, we got them. We got them all. So I bring it out a little bit, and I'm watching this corner right there. Everything looks fine. Oh, I have got an edge here somehow or another. So what did I get? I got 5 edges. That doesn't seem quite right. So hold down Control. So you see, look at that. I got that one by accident. So you can, I'm holding down Control so I can see my edges, and then I could let go, and now it'll apply it. So what happened was I selected this one instead of that one. So I hold down Control. I pick that other one, click it, let go, fillet gets added. Okay. So how big do you want to make this? Well, we're at 1.3. Kind of armchair engineering it, figure out, what do you think is going to help with the structure but still not have as much material. Let's see here, 1.5. That seems kind of all right. So now that I feel that it's going to work, 1.5, 2, whatever you think is okay, I want to go back and I want to edit the fillet because there's nothing stopping me from using this fillet, the same one everywhere. So just know that you don't always have to do that. Some people will see like one obvious section, they'll do one fillet, then they'll do another one. Or I've seen other people that are new at the program do one fillet for every corner because they don't know that you can multi-select. So I double click it, and a reason they wouldn't understand that is because if you go to select something, it doesn't look like you can. So you have to again hold down Control, and now I can pick my edges. I get right in there, that's that whole long edge, and I'll sneak right, oops, I missed it, hit a face, click it again to deselect, pick that one, and now I need to follow this line all the way through. This one's going to be tricky, I think. Hold down Control, oh, not so tricky. There it is. Did I get it? Yep, I got it. And I want that one right there. I don't have to put a number in because it's the same fillet, so it's already there. I'm going to get that one right there. I'll get that one there. That one right there. That one. Now I'm kind of going off of my my pattern here, but I'm doing all the ones I can get at right now, but I'm fully aware that I need to get at these ones here. Up there, over here, over there. Okay, there we go. Now, if we were just making this one similar material, like say we're going to print this all out of PLA, and both colors, the inside color here and the outside color, They have they're maybe same manufacturer, they get the same melt temperature. They seem to be very similar outside of just a color change. You could do this all at the same time. If you have dissimilar materials that have a different rate of thermal expansion, contraction, then you're going to have some huge problems with this. You're going to have, in the case of, say, the Delrin, the POM material, or possibly the Polymax, anything that has these higher temp materials, it doesn't necessarily mean because they're higher temp materials, but the higher temp materials are going to have a big problem with the PLA. And as you print this, lots of factors depending, it's going to want to pull in more than, say, the PLA will, and you're going to have it curl up off of the table. And so that could be an issue that you'll have to resolve, and there'll be another exercise somewhere down the road that I'll show on ideas on how to alleviate that. Let's say that they'll print fine. However, you find that they don't bond so well together, that, say, this inside sleeve here kind of sticks to this yellow out here, but if you were to move it around, or in this case use it as a slide very often, or pick the corner of it here, you can easily get it to pull away. If that's the case, then this next thing we're going to do would be very helpful with that kind of situation. So basically where we're going now is to patterns, but what we pattern for the purpose that I expressed, it makes this kind of unique. So a pattern works like this. If I were to make any object, we can just start with a circle right here in the center and extrude this up. Then I'm going to come up here to the rectangular pattern, which is also down here under pattern. We've got rectangular, circular pattern on a path. I'm going to pick that, and then I'm going to pick my object. But you need to, again, pay attention. Are you picking faces or bodies or features? So I want to pick features again. So I'm going to pick that extrude, or I could pick this object in that case, but I'm going to hit that just to make sure. So I've got that whole object, and then you have to select direction. It doesn't just jump there for you. And then our axis system comes out here, and I can pick one of these. You could also pick the edge of a piece of a part that already exists here, which is kind of something we might do in a minute. And then I get these arrows, which I could then drag out like so. And so there is our many parts. Now, if I move this around, you see this value changing over there. So that tells me I'm working with this first quantity. If you look down here, it's the same stuff again. That's this arrow here, that direction. So I'm going to change this to 6. And now if I move it out, you see I've got a bunch more. So I'll put 6 over here for the other direction, which doesn't do anything because they're all right there stacked over top of each other. I'm going to bring them out the other direction so it's easier to see. And now I've got a whole pile of them. You see? I hit OK. And now I've got a little army of pillars. Okay? So that's how we could do that. Now, if I were to undo this, back to this one, if I added extra stuff onto this, like maybe I put a chamfer on it, or a fillet, or what we're going to do in our case, I'm going to use a tool called a draft. And this doesn't need to be there. So a draft, it's better you just watch. It's going to put an angle on this for me. So I need a pulling direction, which is going to be, let's say, this face or this face, depending upon which way I want this thing that's going to happen. So I'll pick this face, and then the faces are going to be the things that I want to come out. So if I scroll it like this, you see it gets smaller or it gets bigger. So now I've got this kind of a shape. I hit OK. Now if I do pattern again, the rectangular pattern, if I do it as features, I have to make sure I pick this one and that one. All the features you got. And then direction, select, and I'll just do 3. So I'll bring it out this way, and then I'll bring these ones out this way, and eyeball it to where you want. Bring it back in, see where you like it. Now, before you hit OK, I'd like you to notice this. I'll just tell you what to do in a little bit, but right now it is saying a distance type is an extent, and that's the full length of how far you want to go. Maybe, probably more frequently, you might do spacing. So this is the spacing from center to center, right? Not the gap spacing, but from actually center to center. So if you want them all, what is this, a distance of, well, those are bigger than I thought, 37 point something or another, maybe we'll say 35. That skinnies them up a little bit, and so then I'll maybe do the same thing right here is minus 35, and then I end up with this grid like so. Okay, so that's a rectangular pattern. I'm not going to do circular right now. I'm just trying to give you a forward on what we're about to do. So this is how I can make a rectangular pattern, and I can pattern multiple features as well. Okay, so we'll go back over to here, and what I'd like to do is I would like to make a pattern of something along the outer face of this, what, tealish seafoam looking thing right here, the inner sleeve. So I'm going to hide that body so I can't see that any longer, and I have this face right here. That's the one I want. So I'm going to pick sketch, and so now what we did for I believe the first time we did in one of the early labs, we picked the top face of a cube, but now I've picked the face of something that's at an angle. It was a flat planar object, but just so that you know, we're on a plane at that angle. And it makes things a little bit complicated because I don't have anything on this cube to line up to. So it looks pretty good, but that's not flat. So I might need to use a different tool down here that's look at, and it's this face here, and now it'll flatten me back out to this face, you see? It doesn't honestly matter if you're looking at it head on, and I would probably recommend that you get fairly used to working on a two-dimensional sketch plane at an angle, because sometimes you need to. Okay, so here's what I want to do. I want to make a feature. I want to make 3 circles, and we're going to extrude them out, and then we're going to put a draft on them like we just did. So I need a center line again. So as we did before, I'm going to pick this edge, this one, and just in case, I'm going to get all of them. And I'll hit P to project, click over here to make them a construction, hit OK, and there we have it. I'm going to hide the body again to make it easier to see. You don't have to, but I like to do that. And then I'm going to draw another line that goes across from center, right, from here to there. Now, since these things are all even, what I can do is I can come up here, I can find my midpoint, and I can bring it down like that. And so now I've got a midpoint right smack there, and I've got a nice line for symmetrical objects if necessary. In our case, what I need is I need a circle right here in the center, one up here and one up here. So I hit C for circle, but look over here. I'm going to hit X on my keyboard to turn that off. So X is for construction. So this is going to be a real element, and I'm going to snap it to the center right there. Then I'm going to bring another one up here. Watch out that you don't get any kind of other entities. You know, if you didn't make this line all the way through, we want the X. The X right here, that light blue X, means we're on the line, but we don't want it to snap to anything else. And then you also don't want to snap, you see that right there? It wants to snap to that other circle. Don't let that happen. Again, if you're in tight quarters where it seems like it wants to snap to lots of different things, hold down Control. So I click, let go of Control, hold down Control, click again. There's my 3 circles. Dimension, this right here is going to be 2.5 millimeters. I don't know why I picked the center one, doesn't really matter. This one's the same as that one. And there we go. Okay, this one is the same as that one. Now, for distance, before I hit the distance, I want to go symmetry. So I'm going to say that this circle right there and this one right there are equidistant across there. Then for dimension, I can pick this one and this one, and I'm going to make them be 16. All right. Now I'll turn the body back on and finish the sketch. Okay. Now, if you recall, our thickness was 2 millimeters. Is that what? No, we made it 1.5, wasn't it? Uh-oh. Uh-oh. I got to go back and look at something here. So this wall thickness of our shell, we have to think about this. So our shell is back down here. So I double click this, and it is 2 millimeters. Right? So remember, if you ever want to go back in time, you know, just figure out where it's at. What I did here is I picked on, say, like this inside here, and it lights up, you see the little lines over the top there, the shell. So it is 2 millimeters. For some reason, I was thinking that we made it 1.5, but whatever. I think that was the fillet. So the thickness of this body is 2 millimeters. I want to extrude this element, these circles, up into that, but I do not want to, I don't want to go through it. Okay, so we're going to extrude these 1.5. Right? And then, well, we're going to pattern them, but before we do that, we're going to draft it similar to what we just did. So I go to draft, and now my pulling direction, if you recall, I picked the top of the other one and it flared the bottom out. Well, in this case, the pulling direction, it doesn't have to be a part of that feature. I'm going to pick this face, and then the faces are going to be all of these edges right here, and I'm going to pull them out a little bit, you see? Something like this. So what are we here? By the way, if you have trouble rotating, when you go to rotate, it should pick your rotational center roundaboutly where you are with your mouse when you go to click. Sometimes gets screwed up, but that's the idea. So you look at that, that's 20 some degrees, like maybe we say minus 20. Yeah, minus 20. Let's go a little bit more than that, maybe 25. Right? So see, that makes an angle that comes out like this. And now, this is how we're going to do a whole lot of work in a lot of less steps. So I need these things on every face that you see here. I don't necessarily need it on the bottom, but I want it on these faces here on all sides, okay? So we start out with a pattern, and it's going to be a rectangular pattern, and the objects are going to be features again. This is always in the way here. So it's going to be features. I'm going to pick that extrude and that draft, and then for the direction, I'm going to pick this edge right here. You see? Now I pull this out like so, except now I can go over here, instead of one direction, I can say symmetrical. And so it's going to make it even. So when I pull this out, it'll go all the way out here. Well, I maybe want it to be spacing, right? And I want more than 3. If you want it to be, if we start from the center like this, go with an odd number, and you'll end up with it even on both sides. So maybe 5, maybe 7, probably 9. So if I went like this, you see, I could bring it out like so. If you didn't think that was enough, then like I said, we could go 9. And you're like, oh man, that's a lot of work. It's no work. There, I just typed it, right? It might make the print a little bit longer, but you know, you decide what you want to do. It's the time versus maybe the quality, if you will. So I look at this and I say, okay, is this good? So I've got 19 millimeter spacing. How about we even that up to 20? And it goes right out to the edge here. And I think that that's pretty good, right? So I hit OK. And if it doesn't die, then I've got a whole bunch of little thingamabobs all along this face. So now do it again on all these sides, right? Well, we're going to mirror it. So there is mirror, again, right here. And what I can do is, instead of having to pick a whole bunch of little guys here, I got features. You want to pick the original. You want to pick the original extrude, the original draft, and then the pattern. And then the mirror plane, well, that's going to be a problem, because you might be inclined to go, well, okay, yeah, there's the plane. I'll pick that one. However, if you recall things not being center, I don't exactly have the right plane. If I pick this one here, they're going to be kind of embedded into it. It's not going to work right. So if I was mirroring them across to the other side, that would work fine. So let's go ahead and do that just so you can see. You see? So those go over to there, and I'll hit OK. And I'm using optimized again. If yours doesn't work, maybe try that. So now look, now I've got a whole bunch of little dots everywhere. Now I need these guys both down below. They would work great if I had a plane right through the center, because I could do all of this all in one shot. So I got to make a plane. So here's a new topic, construction elements. So we talked about construction elements. We talked about construction lines before, right? Of course, the dashed lines. Well, we have other things that they typically call, you know, construction type elements. that are, you know, different types of planes, different axes and points that you can put in different places. So if I wanted to, I could just do simply an offset plane, and I could say I want a plane offset, you know, parallel to that face somewhere. That one's probably the most commonly used type of plane. But what I can also do to make sure I get one right smack in the middle of this is I could do a plane through 3 points. So this one here is a plane through 3 points. If you ponder this, one point is not enough to put a plane on it, right? So if you had 1 point, it wouldn't work. 2 points, it would roll around the 2, it wouldn't work, right? But 3 anchors something in space, great. You do not need 4, 5, or 6 or anything more. 3 points makes a plane. So I hit this, and what 3 points? Well, I want this one right there, and I want something like this one over here, and one of the 2 over on the other side, right? Like this one right here. And then I've got a plane that we know for certain is right smack through the middle of this part. That makes life really nice for us, knowing how to make planes where we want, because otherwise it can be a big struggle trying to figure out how you're going to do something. I have to say, there's never been a situation where I can't get something done in CAD, right? I would probably say that certain CAD programs make it easier to do that, but yeah, you can always get done what you want. Now that I have that plane there, I can go to create, I can go to mirror, and now I'm back at the same deal, objects. Well, I don't want to forget, I want the original, I want the draft, I want the pattern, and I want the mirror. So now I've got everything, and I would like to take these things and bring them across that plane down to there, optimize. Holy smokes, I got a whole bunch of little dots all over the place. So let's see. I'm going to turn these off for the time being. We turn them off and on quite regularly. So now what are we going to do with this? So if you're looking at this and you're thinking about this and that body, you're like, oh, those go up into this. And that is a true case. However, if we went to print this, we would have a huge problem, and your printer would probably, you'd probably end up with kind of a mess. I'm not really sure what kind of mayhem it would cause. But the yellow square, the yellow object out here, it would print solid entirely. And then this bluish one in the center here, it would try to print along with that, with the other thing, with the tabs in there. So we end up with 2 things occupying the same space. Those little tabs are inside here, right? So what we need to do is remove the tabs from this. Do we need to do it all over again and make a whole bunch of little holes in this? No, we don't. This is our next topic in this mayhem of a lab. This is Boolean operations. So Boolean operations allow us to be able to add, join, remove, or intersect one body from another. So this is another thing I should probably show you in a different window. Hugely valuable. So I'm going to make this. I'll do this. I'm going to extrude this up. Something like so, right? And then I make another shape on this plane, let's say, and I'll just make it be, let's make it something kind of a little bit different looking so that you know that it's actually happening. We'll make a shape like this, something that's not a triangle or a circle or, you know, an oddball shape. And so then I extrude this out this way, and let's just make it symmetrical. You see that since it cuts through that body, it automatically defaults to a cutting operation. But I could go join, and it's going to join them together. Now they're welded together. If I look up here, it will still be one body. I do not want that. So what I'm going to do is I'm intentionally going to say that this is a new body. And then I can hit OK. And now they're actually not joined together. It's kind of tough to tell or understand this, but I have a black edge around there, but there's no edge right there for me to grab. It looks like there should be, but there is not. They're in 2 different, you know, spaces, universes, if you will, right? They're separate. This is really the main reason why we have this concept of bodies. So now what I can do is I can say up here, I've got this combine. It really should be called Booleans, but more people, I guess, are going to understand it by the word combine, except combining is by far not what you use it for the most, right? So I go here, and the target body is this one and that one. Sorry, target body is this one, let's say, and then the tool body is this one, and, you know, it'll depend. And if I want to do a join, I hit OK, and now there is an edge there. I can get a hold of that, and I could fillet it if I wanted to, you see? But that didn't make no sense, right? Because I could have done that in the beginning. Also, look over here. It's one body. So I'm gonna take this. I could delete it, or I could just come back here and edit it. That works too. And I can say, don't do a join, do a cut. And so now it's going to cut the one body away from the other. Okay? So now that shape is out of that. Or maybe I didn't want it that way. So now I edit that again. And the target body, maybe I want the target body to be this. And the tool body, the thing is like a cutting tool. Then you see that? It's the same as if I just did an extrude cut through it earlier. So you get it. The other thing I find that's really interesting is this intersect, and it'll combine the two and trim off the edges. So watch this. See the part where they intersect? That's what you're left with. These beginning exercises, when I first demo it like this, or maybe almost always never really hugely, like, doesn't really put the weight of, you know, how possibly cool these things are, but they are. So if you can remember it, remember it. In our case, what we're going to do is we're going to go back over to here, and we're going to remove this blue one from the yellow one, just like we did. So I come up here and I hit combine, and the target body is the yellow one because that's the thing that I want the holes in, and the tool body, the thing that is the cutter, so to speak, is this body right there. Now, if I were to just hit OK, it's going to join them, right? So I want to do a cut, and now I'll get the result that I want. But if I hit OK, notice right here, new component and keep tools. If I hit OK, it will do it. Now I've got these little wonderful holes in here that have a drafted wall on them. But, oops, I just lost my other body. That's a bummer. So there is a section here that you want to remember about. If I double click this, it says keep tools. So it'll keep the tool body as well. So now I've got them both. It doesn't look like anything changed, right? But I've got two different bodies, and if I hide one, this one's got all the little bumps on them. And if I hide the other one, this one has all the little holes on it. So now, if you still haven't figured out where I'm going with this, when you go to print the two of these together at the same time with an IDEX type printer, independent dual extruder, right? The one with two different heads that move at the same time and can print different materials, I can print these two dissimilar materials at the same time, and if I felt that one might be inclined to come away from the other one, like I said, that it doesn't bond so well, we've now got roots, if you will, stuck into the other. So as it prints it, it will print with that element stuffed inside there. I think this is really great. You could elaborate on this a lot if you wanted to. So for example, if you felt that maybe the edges were still coming undone, you could do a lot of work to this. You could have a whole bunch of little dots here, but you might just run a sketch right along the edge right here, just a real thin, like maybe 1 or 1/2 millimeter of a lip here, draft it out so all of your edges are embedded into the other part as well, you see? So this is basically a new little trick that I developed just for our machines, and I think it will be useful for a lot of different parts that you end up making. There are a lot of cool materials that are not very inclined to want to stick together, and I've used it for various different parts that have came out swell. I've also tried to work with a few other parts that, again, their thermal expansion was too bad, so it's still warped off the table, but this concept here is sound. Well, you probably thought we were done, right? Well, we basically are. However, we're going to go back to something that we talked about in the very beginning now. The part is entirely complete. If we knew where we were going, we could have done this thing I'm about to do early on. But as I've also said, we're frequently working with the dimensions that we perceive that we have based upon the lumpy model that we originally made. We get it all done. We get all the features in place. And then we can edit stuff for fitment is where I'm going with this. So this particular piece right here, I mentioned that we need to reduce some sides. We need to make the thickness from this edge right here, you know, this face over on this side to this face, we need to reduce it a little bit to fit within these boundaries right here, because it's by default just sliced away. You know, the distance from this blue wall is what we did. This one to this one over here, 75, I believe it was, is going to be too tight. So if we give it, you know, 1/4 of a millimeter either side, even something like that, maybe 1/2 millimeter, I think 1/4 millimeter would be fine, then we're going to be a lot better. It's not going to have to be wedged in place. The other thing I was mentioning in the beginning was that we need to pull back a little bit off of this. Oh, it's not up to date. That's what that thing means. We'll talk about that later when we get to assembly. But when I add back in the rear block, this gap thickness here. So we're about to do this. So let me make sure that I'm really clear on what's happening. The sides, this side to this side, we're going to reduce at the same time on both sides. But the length of it up here, I want to reduce on just one side, because I want this face to go right up against this, and all the tolerance I want to have over on this side for the fitment of this block, which is because, again, of the holes. If you go back to the very beginning of this 10 years ago when we started this video. So I need to make an edit, but what we're gonna see in a second here is I cannot make this edit where I'm at right now in the timeline without a bit of extra effort. If I change the thickness right now, I'm going to be changing the depth of this counter bore, which maybe we like the way that it's at. I'm going to be changing the thickness of this wall right here. So for example, I could just do this with an extrude. I could pick this face right here. You see? It's probably not what we want. But now that we know that there is a tolerance gap that we want to work with, I could go back to the very beginning when I made this whole entire shape and make it a little bit smaller. But here's what I would like to say. I want it to be I want it to be a feature on top of the other features. I don't want to have to edit my tolerance by going into the sketch that made it. I would like to have one extrude or something similar made up that is just for tolerance. So if I ever need to change it, it becomes easier to find. So let's go ahead and do this. If I add it right now, and when I say right now, I mean in this timeline. I don't mean right now as I'm talking. I mean at the end here of this timeline. What I need to do is I need to go back in time before I made this shell right here, and maybe even further. So if I grab this timeline and I scroll it back here before that shell, now we're here. Oh wait, but there's holes. Okay, I can't have those. So where's that chamfer and where's the hole? There's the hole right there. Oh, that's way back there. Over here, learn to kind of understand how this is laid out, and also you're the one that laid it out, so try to maintain some kind of consistency with how you make things. So I know that this counterbore was an extrude that came from a sketch, but that sketch had two things in it. So there's another extrude, which is the hole that's deeper in it, that was based upon this sketch. So that's how I look at this. You should you know, you do what you want to do, but at least maybe do it consistently. If I make a sketch, usually right afterwards, the extrude has to do with that sketch right there. So I'm going to roll this back before that sketch. Okay. And now I'm to what? I'm to a point to where I have the cavity right there and the original thickness. Well, if I wanted to, I could go ahead and I could bring this back even further. Now, you have to be careful about stuff, though, because if I go to change a dimension, if I change a dimension, you know how we've been using our projections a whole lot, right? If something that I did was a projection of an edge, then as I reduce the thickness, that's going to change the sketch on that face that has that projection, if you catch that, right? So we have to be very mindful of that, but it's also why we're doing this. I don't want to do it at the very end of time because it's going to cause problems, so I need to go back in time, but I need to be kind of careful where I place it. So in case I was concerned, I would look at the sketch that made this to refresh my mind. Does anything on this have a dimension that's based upon this edge right here? So for example, if this was an edge margin, that this was so far away from this edge, if I skinny it up, if I roll back time before this is what I'm getting at. If I roll back time before that and I make this thing skinnier, then that insert is going to be skinnier and it's going to mess up my whole entire assembly. So it could be very concerning. It doesn't appear to be the case. Nothing's measured off of it, but all the same, I'm going to go after this, right? I don't want it before any further forward because then the holes come out. And so then here's how we go about doing this. Again, I could use it as an extrude, but we've got this nice feature called offset face. This one right here, offset face. So I can pick this, and it's pretty much the same as the extrude that I just said, but it will bring it in or out, you see? So I'm going to pick this face and that face. Oops. There we go. And I want to move it in a little bit. So I said we're going to make it, we're going to bring it back like 1/4 of a millimeter. So just minus a little bit. So minus 0.25 millimeters. Hit OK. And now if I were to measure this, instead of 75, it's 74.5. Okay, so that should give us just enough of a gap to fit in nicely. And nothing, you know, check your work along the way in the widthwise here will be a problem in the future. So then you roll it all the way forward to make sure nothing has an error. And if you had something that had an error, a blatant error, you would see something yellow down here. Maybe something would pop up over here to tell you. Examine everything. Make sure that you think and believe that everything is working the way it's supposed to. Maybe take some measurements and such to see if it still fits. Maybe bring in the other elements if you had made some of those already to make sure that, you know, nothing is clashing. But all looks good. Now, the length. And I think I want to say that these last couple things are going to be finally the end of this. I need to shave off a little bit from the end. The end. So which is the end? Well, that's going to be a first part of this. I need to define what is the front. And as far as front and rear are concerned, this piece right here, I'm going to hide this for a second. That piece is going to be even and centered within this circle right here. We're gonna get it right. Well, we're gonna get it right up against this face is what we're going to do. Okay. I would like it to be right in the center of this circle. This circle is the main center point. We don't have a main circle center point through our part, but I could add one. I could add an alignment sketch, another big topic. Okay, so I could add an alignment sketch to my existing model. So when it comes to joining things together, which I know we have not done yet, I have something that I can anchor the two things together. So concept to come up in the future here, not so distant future. If I need to stick things together, I need to stick this bluish grayish thing to this, you know, the green face right here. How do I go about doing it? Well, this thing has some holes in it, and this thing has some holes in it. What I end up doing is I create a joint that says I want to take this round thing with this round thing and stick them together. So it lines the other side of the hole inside here with the other hole that's on this. So things we don't have to understand quite yet. I need to do something to this to make sure I know which one is the front. There is an element that I need in the future, so I might as well add it now. So I'm going to make a sketch. And I'm going to place it somewhere. And right now, I want to say that I would be thinking very deeply about what I do next. Because I go, oh, I got that plane right there. I'll click on that. Well, wait a minute. Is that plane really on this face? Have I subtracted this face a little bit yet? Have I done anything to it yet? Geez. Maybe I could just pick this face. That might be okay too. Is it anywhere different from another thing, right? So consider that before you just arbitrarily grab something. I can tell you, I was careful about this when we began this. The original square that is the yellow that ended up getting subdivided and all that was all based upon this sketch right here. This is still true. This is flat with this. If you ever needed to, measure it. Hit inspect from here to that flat face, see that it's 0. So I'm going to pick this, and I'm going to make this the front. And the way I'm going to make it the front, or the way visually I'm going to make it be the front, is, that is not what I wanted to press. I'm going to draw a line from right here straight up. Okay, it's a solid line, so I'm going to click it. I'm going to hit X to make it a construction element. It's not hugely necessary, but I'm doing it. Then I'm going to put a circle on here somewhere, not anchored to the middle, just somewhere on here. I put the line here so that I could take this sketch and I could move it up and down on here based upon something else that I'm going to do here in a moment. Should I dimension this? I don't really have to, but I'm going to just for the sake of. Now, the next thing I need to do is I need to give this a dimension that is the center of the whole entire assembly. That part, the center of the lead screw, the center of the knob, all that stuff that runs through the center. So what is that? In relation to this part right here, well, the whole vise base is 40 millimeters thick. However, this is at least, 5 millimeters thinner than that. Okay? So I can't put it in the center of this, but I do know that the bottom of this is the same as the bottom of the mill vise base. This is a common plane, if you will. So I'm going to pick from this to that right here, and I'm going to make that be 20. Again, some very careful thinking you have to do here when it comes to trying to decide all this. So I'm going to hit escape and I'll show you what I'm talking about. If I go back to the assembly and I bring back the inner slide, this is what I'm talking about. The bottom of this is flat with this. There is no tolerance added or anything. They are the same. Okay. And that hole that runs right through the center that the lead screw and everything else is on is right smack in the center of that base. If you recall, I mentioned that earlier on. All right. So great. We've got that. Can go back to here. This tells me that that's the front. Now I can know that I need to remove a little bit off of this back end back here. So if I go backwards, in time, I want to go back far enough to where this is one unit again, to where I can just move something back just a tiny touch. But I want to do it after the holes were made. So watch, let me roll the timeline back. So watch, if I go back a little bit, see my sketch up there? It's gone. I could just know that don't turn the model, because now I know that that's the front. We'll look at that in a second. So I roll it back a little bit further. The holes are gone. Okay. If I reduce this face now, anything, if this reduces, then this center point possibly might move that we have right here, right? Because it was based on this midpoint line. So that would be a problem. So I do not want to roll back prior to the hole creation. So I'm going to get up here until the holes are made and they're mirrored on both sides, and then maybe take a peek. What's my next elements right here? Well, this is where we started to make the sketch to do the division there. That's a good place to be. It's about ready to be divided, right? So this is the spot where I want to be. Why? Well, let me show you. So now if I go modify, offset faces, and I pick this face right here, I can bring it out or I can bring it back, and notice, see, look, there's the holes. It doesn't affect the hole placement. So if I hit OK, we're good, you see? So I managed to shave off a little bit of material. In this case, it was a lot, but I shave off a little bit of material off the end of it without affecting hole placement for the lining up of the holes to the main body of the vise. So how much do I want to take off? All I want to do is 1 millimeter. So -1. That should be good. If you feel a little bit nervous about that, go ahead and make it 2, because having a gap under there is not going to be a big deal. Now, also as far as fit goes, it might be necessary, possibly, to shave off a little bit off the top. Just maybe a couple, 0.2 of a millimeter or so. If you believe or feel or think that this any kind of print discrepancy or warpage or whatever might not get this to sit flush up against that face really well. That might leave a little bit of a bump down here. But you don't want to mess with your hole alignments, but that could be the reason you need to do this, because maybe you try to adhere these, bond these two together, fasten them together, and maybe your holes seem like they're not lining up by a really small amount. Again, it might be your fitment right here that maybe you need to shave this down by just a tiny little bit. The holes will belong where they go. If you were to shave a little bit, again, you would just have maybe a small little gap right there, right? And that's all, that's it. For the sake of, it's a 20-hour print for a lot of this stuff, you could go and drop this down a little bit. I would say drop this down right about now too. We don't want to affect the hole placement. However, we do have some projections in the future that are what our cut is based off of. So this might be a bit more problematic. So let me roll forward in time, make sure I don't have any errors. So I'm going to keep rolling with this, and I know that it's probably a little bit on the spooky side here, but let me just kind of talk as I'm going. If I did it at the very end, I'm going to thin this wall out, which I'm not horribly concerned about, because again, it's going to be like 0.2 millimeters. But if I want to be, a little bit maybe better with it, what I could do, I believe, is I could come back here. Here's the shell where that happened, just after the body split. This might be where I want to do it, because that shell now will include that tolerance. So if I go here to modify offset face, this one and this one, and then I say minus 0.2. I brought it down just a tiny little bit. I hit OK. And now when I bring it forward, the shell will still have a 2 millimeter thickness everywhere. And it's okay. It's not affecting this line right here because this inner part here was already created. It's not at the very end, so I don't have a little bit thinner wall. But I still will roll it forward because I'm doing this as, oh yeah, see, I'm doing it as I'm thinking, and I could very well cause a mistake. So as far as things blowing up, this is great because now this becomes kind of hopefully a final learning lesson with this lab. What do you do? What do you do when this happens? Well, I want to kind of analyze this and see where, if everything else looks right. This is also why we like the assembly concept, because any other problems will probably, hopefully, show up if you look close enough in the assembly. So what's going on now? Well, I changed the dimension. I changed the height. There's this height up here, and somehow or another, it caused a problem with this sketch. So I can go here and I can double click on it and I could edit it. I could also right click and review the warning, and oh, it's a projection. So even though we didn't change the face down there, see this yellow right there? It's always really hard to see. I could turn off the bodies here, and maybe you can see it better. This is their error warning. It's saying that there's something wrong with this. So I could redefine the projections. So if I wanted to, let's see, let's review the warning. So here's my project. It says that the reference is lost. So even though we didn't change that thickness, some part of it, usually typically a name or something, has been changed. Since I changed the thickness, now that becomes edge face wall number 17 instead of 16 or whatever the case may be, and it doesn't know any longer. Other programs tolerate this a little bit better than Fusion does, so it is what it is. I could try to fix this here, or I could just select the whole thing, delete it, bring the body back, and I could reproject it. Oops, wrong guy. So I'll reproject that. So now if I hide that, you can see there's a little dash line there. And then I could dimension this again. Nothing's moved, so it should still be 20. If it was not 20 on the money, then you know that you changed something bad. But it is the same as it was, so all is good. I could exit out of here, and my sketch isn't yellow any longer. I could bring this body back. And there we go, okay? So just a simple little part, right? That was probably might be the longest CAD lab I've ever done, I think. A lot of stuff going on here. I'm also talking about this. This would normally be, if this was a CATIA class, for example, this would be broken out over the course of many lessons, but this is trying to get as much information in a proper way to you all in one shot in the context of an actual product. So I'll probably break this into many different videos and I'll try to condense it wherever possible, but it is what it is. I feel like, you know, that's the point of this, is we're making real life parts in an assembly, not just how do I make this damn part right now in front of my face. Just give me the dimensions. Okay. So that's it. Moving on. Next one is most likely going to be now the outer body of the vise. Okay. There is one last thing. So here's the assembly that we've been looking at the whole time. I have hid the inner slide that was already there before, already done, and we know that it fit, and our holes line up right through the center right there. So what I'm going to do is I'm going to hide it again, and I'm going to bring in the part that we just made. So we bring this one in like this. This is the joining and everything that I was talking about. So this just brings it in wherever. That's fine. I don't care. It just goes right there. I want that circle to be lined up with this circle right here, the centers. It's going to be the center to center and the face to face. This is why we did this. And then we can check it in the rest of the context to make sure that everything we did is okay. So based upon measurements that I took from this as we're going through the lesson here, we've got holes that we place on here. Will they line up? Okay. Well, I hit J for joint. So I hit J and it wants me to select a thing. So I'm going to hit this edge right here. Some secret tricks that we'll talk about later in assembly. I need the center point of that, but that's not maybe really it. So I hover over this and it shows there's a center point, but if I move away, it goes away. I hold down Control. Now it doesn't go away, and I can pick that center point. Okay, that's the center of the circle. Then I come over here. I catch that edge right there, and I hold down Control so I can come over here and I can pick the little circle in the center, and kapow! They join together. Okay. So then hit OK. And now let's check our work. So that should be right smack up against there. But look right here. There's a tiny little gap. That's interesting. How far is that? So let's see. Let's rotate it around from there to there. Oh, look, it's 0.25 millimeters. We've got a 0.25 millimeter gap as we do over here as well, right? So that's great. So that's what we wanted. And then if we look back over here on this side, we've got a little gap right there, right? It looks to be flush along the bottom the way we want, and even a small little gap right along the top that we did. But did our holes line up? We did not join the holes together. We did not pick a hole and say this hole lines up with this hole. We said make the center of this thing line up with the center of that. So, right? So if anything is off, holy smokes, you know, it's not going to line up. So I'm going to pick this here. I'll line it up with that. Bam. Spot on. I would say very much so, make sure you look at all the holes because maybe you got the dimensions wrong, but we're good. So you see? So this is the, just in a small little nutshell, the huge benefit of being able to design in context in an assembly, using assemblies, so that you can check all your fit before you build.